So here's a bit of a trickier question that involves the area inside a polar, and we're trying to determine the area of the inner loop of this equation of r equals 2 plus 4 cosine theta. I went ahead and graphed it so you guys can see what it looks like. If you don't know how to graph this, you guys could probably refer back to the graphing videos. But as you can see here, we have this inner loop, and we're trying to find this area. So how do we do that? Well, remember what our polar equation is. So we know what r squared is. It's just this function squared. But what's really difficult in this question, and usually what's going to happen, is finding these angles. What are going to be the angles that'll give us the area of just this tiny little loop? So notice that this graph starts off here, and it kind of follows this curve up until it reaches this 0. Once it reaches this 0, that's when this loop starts. And once it gets back to this 0, sorry, here, I'll do that again so you guys can see. It starts here, the graph reaches this 0. Once it reaches this 0, that's when the inner loop starts. Okay? Keeps on going, and once it reaches the 0 one more time, that's when the inner loop ends, and then it finishes off the function. So what we need to find is when does r equal 0? When does this graph hit the pole? So we're going to solve for r equals 0. And we can do that pretty easily. We have the equation for r. So we just do 0 equals 2 plus 4 cosine theta. Turns out to be negative 1/2 equals cosine theta. And that occurs when theta is equal to 2 pi over 3 and 4 pi over 3. Remember, this graph has a period of 2 pi. In 2 pi radians, it'll go all the way around. So we're just looking at the values between 0 and 2 pi that give us that satisfy this equation. So now that we have this angles, that's pretty much the angles that we're going to use in this equation. And notice that remember when we were graphing, whenever it hit the pole, we were coming in tangent to that angle where it hits the pole. So notice that this is coming into the pole tangent to this line right here. And it comes back to the pole tangent to this line right here. And as you can see, this is simply 2 pi over 3. And this tangent line has a slope of 4 pi over 3. So that's how you can kind of visualize it and check to see if you're right. And let's go ahead and solve for the area now that we have all the parts of the equation. The area is going to be the integral from 2 pi over 3. And remember, first it hits 0 at 2 pi over 3, and then it goes to 4 pi over 3. If you did the opposite, you'd get the opposite of your answer. So make sure you're remembering which angle correspond to starting the loop and which angle corresponds to ending the loop. So now we can just plug in 1/2 times r squared. And from here, math gets a bit tricky again. Gonna need to remember some trig identities. You have 1/2, and if we do this, it turns out to be, well, we have our first term squared plus 2 times the product of the two terms plus the second term squared d theta. And now multiply out the 2. We get 2 plus 8 cosine theta plus 8 cosine squared theta d theta. I'll go ahead and copy that again on this new sheet of paper. What we had was the integral from 2 pi over 3, 4 pi over 3, that's just that. I didn't do any steps. So now we're gonna kind of have to remember back to some trig identities and use the fact that cosine squared is equal to 1/2 times 1 plus cosine 2 theta. And we have a cosine squared theta. So the integral from 2 pi over 3 to 4 pi over 3. So those stay the same, plus, well, we have this 1/2, so we need to take for account that with the 8, since we have 8 cosine squared thetas, and this is just one cosine squared theta, if we multiply both sides by 8, we'll get a 4 over here, because 8 times 1/2 is 4, and then we just have that 1 plus cosine of 2 theta. And from there, it's a bit easier to integrate, since now we can just multiply that out. We have 4 times 1. I'm going to kind of do a couple steps at once now. Let me write these first. So we have, let's just look at the constants. We have 2, and then we have 4 times 1, so that gives us 6. If we look at the cosine thetas, we still just have 8. And then we have 4 cosine 2 thetas. And to integrate that, well, we can just integrate each piece individually. So 6 with respect to theta is just going to turn into 6 theta, plus the integral of 8 cosine theta is going to be 8 sine theta, plus 4 cosine, integral of 4 cosine 2 theta, we need to divide by this 2, gives us this 2. The integral of cosine theta is sine theta, and the angle stays the same. We're evaluating at 2 pi over 3, 4 pi over 3, and you guys can do that on your own, and you should come up with 4 pi minus 6 root 3, or if you use the calculator, 2.174. So as you can see, sometimes these types of questions get trickier, but the really difficult part is to find what these angles are to use in this equation. And that's it.